Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models, they just launched dedicated CPU instances. Go to pythonpodcast.com/linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, Corinium Global Intelligence, and Data Council. Upcoming events include the O'Reilly AI Conference, the Strata Data Conference, the combined events of the Data Architecture Summit and Graph Forum, and Data Council in Barcelona. Go to pythonpodcast.com/conferences today to learn more about these and other events, and take advantage of our partner discounts to save money when you register. Your host, as usual, is Tobias Macey, and today I'm interviewing Boris Paskalev about DeepCode, an automated code review platform for detecting security vulnerabilities in your projects. So, Boris, can you start by introducing yourself?
Hi, my name is Boris Paskalev. I'm the CEO and co-founder of DeepCode. We're currently based in Zurich, Switzerland.
And so, can you start explaining about what the DeepCode project is and some of the story of how it got started?
So ultimately what DeepCode does is learns from the global development community every single issue that was ever fixed and how it was fixed, and combine this knowledge of all development, almost like crowdsourcing the development knowledge, to prevent every single user from repeating those mistakes that are already known. In addition, we actually have predictive algorithms to understand issues that might not have been fixed but could actually appear in software development. And where we started, so ultimately the idea started by the other two co-founders. They actually spent more than 6 years in researching the space of program analysis and learning from big code, which means like billions of lines of code that they're available out there. And they did that in ETH Zurich, which is what we call it the MIT of Europe. And they're one of the foremost experts in the world in that space. They have hundreds of publications in the space. And and when they finished the research, our CTO Veselin, he published his PhD. It was super well awarded. And we decided that it totally makes sense to actually build that into a platform and revolutionize how software development works.
And was there any particular reason for focusing specifically on security defects in code and how to automatically resolve or detect them?
Actually, security was a later add-on. We actually did that in 2019. It was just started this year, and we published a specific paper on that. The platform itself is not targeting on anything specifically. It can any issues that's fixed, being that a bug, performance, you name it, can be detected. Security was just a nice add-on feature that we did, and it was pretty novel as well.
So, in terms of the platform itself, can you talk through a bit about how it's implemented and the overall architecture for the actual platform and how it interacts with a user's code base?
So pretty much what it does is there's two steps both in the learning and analyzing code. The first step is we take your code, we analyze it quickly, we convert it, we use standard parsing of each language, and then we actually do a data log extraction of semantic facts about the code. So we build a customized internal representation about the various interaction, every single object, how the object propagates and interacts with functions, getting into other objects, then how they change, etc. And this knowledge represents pretty much the intent and how the program functions, right? And then we do that for every single version of the program. So we see over time when people commit code and change code how that changes, and that gives us the delta, what is changing and how people are fixing things, right? Then we do that extremely fast, and we do that over this hundreds of thousands of repositories, obviously, and like billions of lines of code. And then we actually identify trends. This is where our machine learning kicks in, and it identifies trends, how people fix things, what is the most common things, are there specific weird cases, etc. And this is how we build the global knowledge, as we call it.
For the languages that you're currently supporting, I noticed that you're focusing, at least for the time being, on Python and JavaScript, and I believe there are one or two others. And I'm wondering what your criteria was for selecting the languages that you were targeting for evaluation and automated fixing, and just some of the other languages that you're thinking about targeting next.
Yeah. So pretty much we started with the most popular languages out there. I mean, there's different charts, but kind of the standard suspects are obviously Python, Java, JavaScript. Then following down that line, we're looking at obviously C Sharp, PHP will come, C and C++, and down the list. I mean, we're getting more and more requests for various languages. So it's a combination of the ranking of the language and popularity, as well as specific customer requests, specifically big companies if they're asking for very specific.
Given the dynamic nature of things like Python and JavaScript, I'm wondering what some of the difficulties you've faced are as far as being able to statically analyze the languages and avoid any cases where there might be things like monkey patching going on or maybe some sort of code obfuscation.
Yeah, I mean, so since we don't do the typical static analysis here, we're doing actually a static semantic analysis, and we do that in context, right? So that allows us to go much deeper. For example, if you have a particular object and then you put it into an array, and then the object comes out, we still know that it's the exact same object. So that kind of gets us closer to a dynamic analysis as well. So that's kind of some of the features that allow us to statically analyze and identify much more complex issues that are close to dynamic interprocedural analysis, if you say, and this allows you to get much higher accuracy, not have the false positives that other tools will throw you there, and as well identify issues that classical syntax static analysis will not be able to see at all.
Another thing that can potentially complicate that matter is the idea of third party dependencies and how that introduces code into the overall runtime. And I'm wondering how you approach that as well, particularly as those dependencies are updated and evolved.
Pretty much for dependencies, we scan the dependencies code if the code is included in your repository. We don't have there are many other services out there that have a list of dependencies in their version saying which one might be having issues or not. We don't do that because that's pretty much static databases that do that. But we do look at how do you actually call specific APIs. So if you're actually calling, you have a dependency and you're calling some kind of a function from it, we're actually going to identify how you're calling the function and telling you, hey, you're not calling the function the right way, or the third parameter that you're passing in is not the right one, etc., etc. But specifically, what dependencies you incorporate, we don't actually look at it. I mean, we can tell you you're importing things more than once, or you're importing something you're not using it. Things like this we can have as well, and that's kind of the scope that we go into.
Another thing that introduces complexities is as languages themselves evolve and introduce new capabilities or keywords. And I'm wondering how you keep up with those release cycles and ensure that your analyzers and your recommendation engines are staying up to date with those capabilities. And then also on the other side, ensuring that any recommendations that you provide in your code reviews match the target runtime for the code base as it stands. So, for instance, if somebody wrote a Python project that's actually using Python 2, that you don't end up suggesting fixes that rely on Python 3 features.
So on the first one, when languages change and evolve, which is again pretty common these days, so there's two things, right? First of all, is are the parsers supporting the new feature, right? Because we have to get the latest version of the parsers. If the parser is supporting it, that's great. If the parser is not supporting it, then we have to do our own extensions until the parser starts supporting it. Because we pretty much use standard parsers with minimum extensions only when needed, right? So this is the standard feature. If there's something fundamentally different about the language, right? This is where we might actually have to extend our internal representation to support that. Like, like if it's something like really fundamental, but that's we rarely see that in specific languages. That's more happening if you get a new language, right? So that's kind of the two major branches when new things comes in. But for the majority of things, there's very little that we have to do, but extending to the latest parser. The second question that you ask is kind of the Python versions, Python version 2 versus 3. So we don't specifically differentiate that, but when we give you suggestions, we will tell you, hey, for Python version 3, you have to be doing this, right? If you're doing if you are in Python version two, obviously, you can just say ignore these suggestions, and you can actually create set of rules and saying, okay, this is all the set of rules that are Python version 3, just ignore them. You can put that into a config file, and until you move to Python version 3, you can just ignore all version 3 rules.
And there, it also gets a little bit more difficult for within Python 3 versions. For instance, if your code is targeting Python 3.5, you don't want to suggest fixes that incorporates things such as f strings or data classes. And I'm curious how you approach that as well, or if it's more just based on what the user specifies in their config as far as the runtime that they're using.
That is correct. So we don't have any very strong changes in that space. The place that helps in that is we actually, all the suggestions we provide are contextually based. So usually you can actually see what's happening before and after specific issues, right? And if they're version specific, then you actually will not get the recommendation because it looks different in your case. That doesn't cover all the cases, obviously. I think you're rightfully asking that questions. And we don't have a great solution for that. We leave it to the developer to actually, when they see the suggestions, say, nope, I don't care about that. Clearly, as I said, we can do it through the ignoring rules, but those changes are rare. I mean, they do happen, and we've seen cases where the developer said, yeah, I don't care about this yet. I haven't updated. And that happens. But we usually target most of our suggestions and learning since it's automated. It gets the learning from the latest version. So if a large percentage of the development community is moving to the latest version, then they're making changes related to it, and you'll be getting suggestions for that as well.
Can you describe a bit more about the overall workflow for somebody who's using DeepCode and how it fits into their development process?
Yeah. So the most standard one that we envision and we see it's most popular out there, it's a developer tool that lives on the Git. So pretty much you log in with your Git account, GitHub, Bitbucket, whatever that is. You see a list of repositories that you want to analyze and you subscribe them, right? Once the repository is subscribed, you're getting two things. First of all, every time you do a pull request, we actually analyze it and we tell you, during this diff, are you introducing any new issues, right? So that's number one, that's continually monitoring the new code being generated. The second piece is continuously monitoring on your old code, because old code could also age, right? As the development community changes, new security vulnerabilities are uncovered, etc. Something that you've written 2 years ago might actually is not secure anymore, and you actually want to get pinged for that, because very few people actually test or look into their code from 2 years ago. So that will give you a ping as well, saying, hey, yeah, this function here, the code has to be updated to a new encryption, for example, to make sure it's secure. So those are the two major pieces. Again, fully lives into the Git. And in addition to that, we obviously offer an API and a command line interface. So you can really integrate our solution anywhere you want. It could be as part of continuous integration. We actually have that in GitHub already, that if you finish the pull request before the merge, it can tell you, hey, we analyze it. There's no critical stuff. Please proceed. Or, hey, here's one critical stuff, critical issue. Look at it. But yeah, the API and the command line interface allows you to really like script within minutes a checker at any point on your workflow, because developers and different companies or setups have very different development workflows, and they might want it at different stages. If you're having a QA team, if you're having continuous integration, if you're having a continuous delivery versus individual builds every day or month, whatever that is.
And then in terms of the model itself, can you describe a bit about the overall process that you're using for training and some of the inputs that you use as far as curating the projects that you're using as references to ensure that they're of sufficient quality and that you're not relying on something that is maybe using some non-standard conventions?
Yeah. So 2 points on this. So we do have a custom curation. It takes a lot of different things: how active the project is, how many contributors, how many stars, etc., etc. So that's continuously updating. And this is mainly done because there is a lot of stale projects in the Gits, like that haven't been touched for like 2 years, or have one developer only that never touches it. So that there's kind of a long tail of such projects. So we just don't want to waste time to analyze them. The machine learning automatically actually seeds out such a kind of a poison pills in a way. Kind of random developer have fixed something in the wrong way, right? And this is where it comes in with the probability that actually the probability we assign to every single suggestions that we have, which is based on how many people have fixed it this way. Is there a trend, a lot of people fixing it? How many counter examples there are, and how many actual such issue exists in the open source community today, right? So based on that, we can automatically see issues, because when you fix something wrongly, it's very unlikely that there's many people that have fixed it the same wrong way. That only happens, for example, if somebody publishes a wrong solution on core and nobody catches it, and that can happen for like 1-2 weeks, but usually that gets resolved immediately, and then our knowledge base will automatically update.
In terms of the amount of domain expertise that's necessary for identifying those faults that you're trying to detect, I'm curious if you're using sort of expert labeling techniques where you have somebody going through and identifying the faults that were created and the associated fixes, or if you're relying on more of an unsupervised learning model for being able to build the intelligence into your engine.
Yeah, so it's mainly unsupervised learning. We actually do have some labeling which is based on how severe the issue is. So we have categorization of critical warnings and info type of suggestions. So pretty much we have to actually categorize which ones are critical. And this is where our team does that, but that's on a type of issues. So like within 2 hours, you can label like hundreds of thousands of different suggestions. So it's a pretty quick process. So it's very minimal supervision that we have to do. Everything else is pretty much fully automatic. What we do, we automatically detect the type of issue. Is it a security? Is it a bug? Is it the performance, etc.? We use a number of techniques there. We have an NLP on the commands, obviously looking at the specific code and semantically what it does. Because what we do, we have a predictive algorithm that infers the usage of specific functions and objects. So we actually know what they do and what setting they're being used.
And you mentioned too that for the pull request cases, you're relying on parsing the diffs of what's being changed. And I'm curious if there are cases where the diff just doesn't provide enough context about the overall intent of the code, and any approaches that you have for being able to mitigate some potential false positives or false negatives where you missed something because of the fact that the code is only changing maybe one line, but you need the broader context to understand what's being fixed.
Okay. So yeah, sorry. So maybe I didn't clarify that correctly. So we do analyze the whole tree. Like we always do the full analysis, right? But usually the semantic changes are only within the diff, and we actually show you what it is. So if a change that you make on this line of code is causing a security issue somewhere else, we'll actually catch that out, absolutely. I mean, we cannot analyze anything smaller than that because our internal representation requires the context of what's happening. So we have to analyze every single function and procedure to see what it is. So we will analyze everything, but usually the changes are happening only in the diffs because they are focusing there, but it could be in a different part of the code base as well, where the issue comes from. In terms of, you mentioned false positives and false negatives again, so there's a number of techniques to lower that. I mean, we have kind of a record high accuracy rate compared to any of the existing tools today, and that's mainly based on the contextual analysis. So we actually know in what cases the problem is there, and on the fact that we actually have kind of usually thousands of examples. So it's a pretty accurate what it is. And we're not doing a syntax-based comparison. We're doing a semantic comparison. So we're not looking at what you're doing in the specific lines of code, because without knowing the semantic details about it, you actually could be very wrong. But looking at semantically gives you the considerably high accuracy rate.
And in terms of identifying those false positives and false negatives, if you do identify maybe a false positive, and is there any way for the users to be able to label it as such so that it can get fed back into your machine learning model so that you can prevent that from happening in the future, and just any other sort of feedback mechanisms that are built in for users to be able to feed that back into your model to improve it over time?
Yeah, so we have two ways. First of all, is you can ignore rules for your own. You can say, "It's hey, this rule I don't like," and you can decide if you want to do this for a project or in general. And the second is you can actually have a kind of a thumbs up and thumbs down with a comment saying, "Yeah, I don't like this because blah." Right. So this is the two main mechanisms that we look at. It is clearly for open source. We actually get the feedback automatically if an issue was fixed or not. Right. And that, as I said earlier, we'll look at how many of the issues exist in the code base out there, and how many of these type of issues have been fixed, which is part of our probability assessment if an issue is should be flagged or not.
And in terms of the code that you're analyzing, I'm wondering again how that feeds back into your models, particularly in the case where somebody might be scanning a private repository, and if there are any sort of intellectual property in terms of algorithms or anything along those lines, and preventing that from getting fed back into your model so that it gets surfaced as a recommendation on somebody else's project.
Yep. So we do not learn from private code. At least that did not become part of the public knowledge, right? We have a special function that you can learn from your private code, and that becomes your own knowledge. That usually is for larger companies with larger code bases. When we analyze code, we don't learn from that code, right? We only learn from the open source repositories, and depending on the licensing, there's some open source repositories that you can see but you cannot use, right? So for those, we're not gonna ever create a suggestion examples coming from there. We'll still count them as how many times we've seen that issue and or that it should be fixed, but we'll never show it as an example for fixing. The examples will only come from a fully open source project.
And in terms of the overall challenges or anything that was particularly interesting or unexpected that you've come across in the process of building and growing the DeepCode project and the business around it, what has been something that was sort of notable in your experience?
Wow, that's an interesting question. I think the one that it's more shocking is the number of different technology innovations that we have to do. I mean, we create new versions of the platform a lot. Like, we actually literally about to release a new one in a matter of weeks. We released it to some pilot customers already. That considerably increases the coverage while maintaining the same high accuracy. But yeah, so it's really like we have to come up with new things all the time. I mean, we have half of our team is focusing on really inventing new stuff. We do publish about half of them, because those are pretty interesting findings. Some of them we keep internally because obviously they're a bit proprietary, and over time they come out obviously. So yeah, so it's really the sheer volume of new things that you have to build. Like, there's so many modules. When our CTO starts drawing the whole architecture, like, takes hours and it's a bunch of small boxes, and each one in its own, it's kind of a different innovation that came up, and that's really interesting. And I was not expecting that, and I was not expecting that 2 years ago when I started looking into it. And when I look at it today, we're still doing a lot of that. And when I look at the roadmap, a lot of new things are coming in that space as well. So that is, yeah, quite interesting, and explains why they have never been a platform so far that really goes deep into understanding code in that way, and then being able to learn from such a large set of big code out there in a extremely fast way.
In terms of the platform itself and its capabilities, what are some of the overall limitations and some of the cases where you might not want to either use it or avoid some of the recommendations that it might come out with just because of some of the artifacts of the code that you're trying to feed through it?
Fair question. So no limitations in general. It's fully scalable, can support any language. That's the best piece of the architecture. Specific areas that you don't want to use it, we haven't found one yet. I mean, ultimately, that's part of the basic building blocks. Maybe when we start delivering some more higher level architectural analysis, some of those spaces might come up, but that's still to come. But from the basic building blocks, finding bugs and issues in your code, yeah, there's we haven't found any specific areas where they are. I mean, some projects might have a little bit higher false positive rate versus another for specific reasons, as you mentioned, the Python version, for example, using Python version 2, and we're giving you a lot of Python version 3 suggestions. But other than that, there is no industry or language or focus specific.
And another thing that is a potential challenge are cases where the code base itself is quite large. I'm wondering if you run into any issues where you've hit an upper limit in terms of just your deployed platform for being able to parse and keep the entirety of that structure semantically in the working set, and any strategies that you've developed to be able to work around that.
The platform as designed can literally handle anything. And yeah, millions of lines of code in seconds. So, I mean, think about it. We are learning from billions of lines of code. And in order to do that efficiently, we've built some pretty efficient algorithms to actually do that. And so we haven't seen, like, and we've analyzed some pretty big code bases, any issues. Like, and usually people are like, wow. So we are on average, when I compare it to other tools, 10 to oftentimes 100 times faster in the analysis space. So yeah, I think that scalability is definitely not an issue. I mean, it happened a couple of times that we ran out of hard disk space because of caching. But since we're in the cloud, it was pretty fast for us to add more.
Yeah, I was just thinking in terms of some of the sizes of mono repos for the Googles and Facebooks of the world, where it takes potentially hours to actually clone the entire history of the project and some of the workarounds that they've had to do. But I'm sure that that's the sort of 1/10 of 1% case
Yeah.
that code is even of that scale. But I was just curious if you had ever run into something like that.
Yeah. But you're right. The cloning is the slow part. So on those large issues, large repositories, usually cloning takes a while, and then analysis takes much faster. In our case, so that's really now we actually separate and we show that we are cloning, so people know why it is slow. But yeah, so cloning does take sometimes the slow, especially if you do it over the network in the cloud and it's a large repo. But then the analysis is much faster than the cloning.
What are some of the other user experience tweaks that you've ended up having to introduce just to improve the overall receipt of your product to make sure that users are able to take the full advantage of it?
I mean, the areas where we've toyed a little bit is specifically explanations, trying to actually explain to the customer what the issue is. We've actually had to release, that was another new engine just for that, because people were saying, yeah, that's a bit confusing. And yeah, so we actually had to build on that. UI perspective as well, people understanding what's what. That's obviously work in progress. On the website, specifically explaining to customers that their code is secure, that we don't use it, we're not going to display it, as you rightfully asked, to other customers. We're not going to use it for anything else. We're not going to store it. I think there's other companies that had issues with that, so we're very diligent in that. But yeah, those are kind of the major areas out there.
And looking forward, what are some of the features or improvements that you have planned for the platform and for the business?
So key one is it's our internal main KPI that for this year is the number of actual issues like recall that we can find. So that's as I mentioned, it's going to be coming up very soon. So expect something like 4 to 5 time increase in the number of issues that we can detect. So that's pretty exciting. I mean, other things that we're looking at is we're doing automatic code fixing. We're starting to look into that right now, but that's likely it's early 2020 release. So being able to kind of give you suggestions how to fix it automatically, so you don't have to even write the code or try to understand it. We don't recommend that, obviously, but the capability is going to be there. The other one is, as I mentioned, trying to analyze the code on a more architectural level, like semantic level, and describe what it does. I think that's another big one. I mean, we're toying with some more interesting stuff like test case generation, fully automatic as well. But that's more of a we have to see the results, how commercially viable that will be. But yeah, many different spaces. We have quite a long roadmap of cool things that will come up. And on purely operational stuff, getting more integrations, obviously. People are asking for different integrations. So we're going to be releasing quite soon our first IDE integration, where developers will be able to just directly get the results in their IDE rather than having somewhere else. And hopefully if that spans out well, we'll kind of open it up so anybody can build any IDE integrations, because there's quite a list of IDEs out there.
Yeah, being able to identify some architectural patterns and ways that the code can be internally restructured to improve it, either in terms of just the understandability of it or potentially the scalability or extensibility, would definitely be interesting. And also, what you were mentioning as far as test cases, either identifying where a test case isn't actually performing the assertion that you think it is, or cases where you're missing a test and being able to surface at least a stub of suggesting how to encompass that missing piece of functionality and verifying it.
Correct. Yeah. So in the test case specifically, the area that we're looking at is find the test case out there that it's most suitable for exactly what you're doing, because that's human generated already, and it will allow you to maintain it in the long run, which is pretty much the main Achilles heel for all the current test case automatic generations out there, and then adjust it a little bit so it fits perfectly for you. So that's really the focus area that we're going in that space. Which is pretty exciting. As I said, if it pans out to work, it will be an amazing product as well and nice add-on. But yeah, the platform is tuned in a way that we can build multiple products, and we're just scratching the surface of what will come out.
So there are some other tools that are operating in this space, at least tangentially, or at surface value, might appear to be doing something that's along the same lines of what you're doing. Most notable being the Kite project, and I'm wondering if you can provide some compare and contrast between your product and Kite and any others that you're tracking that are in a similar space.
Yeah. So CAD is a great tool. It's a great ID integration. They have some great inline suggestions. The main differentiations between Kite or any other similar tool that is doing static analysis is they look at the code at a much shallower level, right? They actually try to tell you, hey, it looks like based on what you're typing, a lot of other people are typing this, right? Which is almost like treating the code as regular text. Like it's syntax, right? While we're actually doing semantic analysis, we're saying is actually you're typing this, and the third parameter what you're passing in is not right. Actually, the object you're passing in is an int, and it has to be a long or whatever that is, right? So that's kind of the main differentiation. So they have good suggestions that it's mainly kind of autocomplete, so you're a bit faster to type. They go a bit deeper and kind of getting kind of the linter type of suggestions as well. But again, it gives you a higher false positive rate, obviously, because it doesn't go deeper to understand the issue, and it doesn't give you the contextual analysis as well. So that's kind of the main thing. So the accuracy, like recall and accuracy, are the two main things that are measured. So we can find considerably more things, and the accuracy rate will be considerably higher. So that's what it kind of the main differentiation out there. But we do love Kite, by the way. They have amazing UI, amazing design, and amazing community behind them. So great tool as well.
Are there any other aspects of the work that you're doing at DeepCode or just the overall space of automated fixes and automated reviews that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I don't want to go too deeper in the things that are more experimental because they also take time, and I don't want to get people too excited because some of them might take years to be ready. But the space is ripe. That's pretty much I have to say, and yeah, and there will be a lot of new things coming up, and so developers should be extremely excited what's coming up.
And for anybody who wants to follow along with you or get in touch, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose a book series that I read a while ago and that I'm probably going to be revisiting soon. That's called the Redwall series by Brian Jakes, that focuses on a bunch of woodland animal characters and just all of it's a very elaborate and very detailed world and series that he built up with a lot of complex history. So definitely worth checking out if you're looking for a new book or set of books to read. And they all stand alone nicely. You don't have to read them all in any particular order, but altogether they give you a much broader view of sort of his vision for that space. So definitely recommend that. And so with that, I'll pass it to you, Boris. Do you have any picks this week?
Yeah, for me, picks this week, in general, the AI space has been going great. I mean, everybody knows there's no real AI, it's machine learning, but there's a couple of new areas coming in that space, and that's very exciting. It's pretty much applying machine learning to everything or big data. So that's lovely. But in that contrast, because we all do that every day, and that's our passion here at DeepCode, my favorite pick is do a little bit less of that and do some sports and go outside.
That's always a good recommendation and something that bears repeating. So thank you for taking the time today for joining me and describing the work that you're doing with DeepCode. It's definitely an interesting platform, and I'll probably be taking a look at it myself. So thank you for all of your work on that, and I hope you enjoy the rest of your day.
Thank you very much. You too.
Thank you for listening to the show. If you want to hear more and you don't want to wait until next week, then check out my other show, the Data Engineering Podcast, with deep dives on databases, data pipelines, and how to manage information in the modern technology landscape. Also, don't forget to leave a review on iTunes to make it easier for others to find this show.